Welcome to the topic of proving if u equals gx, where g(x) is continuous over an interval, f of x is continuous over the corresponding range of gx, and fx is an antiderivative of fx. Let's dive into the concept. When u equals gx, you are essentially substituting the variable x with u. This substitution allows us to transform the integral from being dependent on x to being with respect to u. Understanding this process is fundamental in simplifying complex integrals. The next step involves exploring the relationship between antiderivatives and derivatives. The fact that the antiderivative of f of x is represented as fx, where f of x equals fx, plays a crucial role in integration techniques. This relationship leads us to the core principle of the fundamental theorem of calculus. By applying the chain rule and the fundamental theorem of calculus simultaneously, we uncover a profound equivalence between the integral of f of g of x cur x and the integral of f of u du. This equivalence highlights the elegance of mathematical connections bridging derivatives and integrals. Now let's delve deeper into the specific formulas derived from these principles. Integrals take the form of f of g f gx dx equals f of u du, showcasing the essence of substitutions in solving intricate integration problems. Antiderivatives are illustrated as f of u plus c equals f gx plus c, providing a holistic perspective on the interplay between functions and their antiderivatives. Transitioning from theory to practice, let's solve a concrete example problem together. Integrating 2x ex squared dx using the substitution method. This step-by-step demonstration illuminates how to employ substitutions effectively, leading to a comprehensive solution and a deeper understanding of the integration process. The practical applications of substitution in integration extend across various disciplines, including physics, engineering, and economics. Its significance lies in facilitating precise calculations, aiding in the evaluation of areas under curves, and solving intricate differential equations. Having explored the theoretical underpinnings, solved a practical example, and discussed real-world applications, it becomes evident how mastering these mathematical principles can unlock new avenues in problem-solving and critical thinking. For a hands-on challenge, try your hand at solving tatspeth x, 2x squared 1/2 dx independently. Applying the substitution method to find the antiderivative fx not only reinforces your understanding, but also sharpens your problem-solving skills. As we wrap up our journey through integration by substitution, remember that practice is key to mastering these concepts. Revisiting examples and investing time in problem solving will solidify your